We got a couple, looks like there might be some seats up front if you guys are looking for something.
Couple seats over there. Probably one more seat over here. All right, let's start. So next up, we have folks from Mesosphere, Dell, EMC, and Diamanti talking about CSI and storage support in Mesos, and I'll let them introduce themselves. And thanks for coming to the talk.
All right, so my name is G. I work for Mesosphere right now, and I'm a Apache Mesos committer and PMC member since 2013. And my Twitter handle is G_U.
James.
Hi, I'm James DeFelice. I'm an engineer at Mesosphere. You can find me on GitHub at JDEF.
Hi, I'm Steve Wong, open source engineer with the code team at, sponsored by Dell EMC. That's a group that works on community open source projects. I've been working on Apache Mesos for about 2 years now, also working on a XRay project that is a storage provider enablement for CSI. And I've also dabbled a bit on Kubernetes.
Hi, I'm Chakravarthy. I'm the software architect at Diamanti. We are focused on storage and network technologies for containers.
Okay, this is an overview of the agenda today. We're going to start out with a state of storage and container orchestration today. Moving on from that, we'll cover the benefits of standardization, which is what the container storage interface is. We'll get into a more detailed overview of what the container storage interface looks like. Then we'll move on from there, since this is MesosCon, to cover the specific details of how Mesos is going to adopt the container storage interface. This is a work in progress, so finally we'll go on to what the roadmap is. You know, our plans are to deliver a release 1, but follow it up with more features. And then we're going to wrap up the day with some directives on how you can participate yourself and how you can help move this forward and have a voice in how this gets done. As I said, we were going to cover 3 perspectives of the state of storage and containers now, and these perspectives are from the perspective of a user of a container orchestrator, from the perspective of somebody implementing a container orchestrator, and from the perspective of a storage provider. We'll start with users. Over the past couple of years, there's been a huge shift where stateful applications running in containers have become pretty mainstream. You know, there was a time where the 12 factors advised you that everything in a container should be stateless, and what that really meant, you can't deliver a practical application that has no state anywhere. You put it off to the side and it wasn't even managed in a container or by your orchestrator. But in the last couple of years, Mesos added support for external persistent volumes, and this made it feasible to run these stateful apps inside a container, having with it under the management of Mesos. And you can see here just a few icons of stateful apps that can be deployed on the Mesos platform in containers. From the perspective of the container orchestrator developers, and these would be Mesos, but also DCOS, Cloud Foundry, Kubernetes, Docker Swarm. These platforms have, over the past years, essentially all added support for external persistent volume mounts, but they did it independently, and as a result, these implementations are inconsistent. You know, they have variations in the couplings to vendor proprietary APIs in the storage front, and some of the platforms even have instances where the storage interfaces all the way to the storage provider are implemented in code that's within the source tree of the orchestrator. And there has been, this will be covered later in the presentation, but some of the orchestrator vendors have discovered that maybe that wasn't the best decision. Finally, from the perspective of storage providers, of which I'm here representing one, we've been in the position where we have to support all of these container orchestrators for our customers, and it's tough to keep up because the interfaces we have to deal with on each orchestrator have been a little bit different. And this hinders our ability to rapidly adopt to new features that come out in these orchestrators. And it also means that our staff, when we put them on these projects, kind of gets watered down because they have to be trained on all of these platforms, and you maybe end up having finite resources and diverting them to this horizontal spread just because of these variations. As an example of this, this is a summary of the state of the world today. This is a spreadsheet showing the storage plugins across all orchestrators, and this is just a cut and paste of a little spreadsheet that, if the screen was bigger, would probably go down a couple of floors below us. But on Amazon EBS alone, there's like 5 storage plugins that are being implemented and being maintained in the world by various vendors. What I use as an analogy, and this is kind of my wrap-up of this whole session as to why we want the CSI, that this is a picture of the electrical outlets and plugs in the world. And nobody wants the world of container orchestrators and storage providers to evolve like what has happened with electricity in the world. In the current situation, users have problems using your device portably. If you go buy a hairdryer and you go travel to Europe, what are you going to do? Buy a new hairdryer, or you buy an adapter for 30 bucks, move to a different country, and you need to do it all over again. This doesn't make sense. So it's bad from the perspective of the user. But if, say, you're an appliance vendor, it's bad for you as an appliance vendor, because if everything was uniform, you'd get a better economy of scale. You could have one product that you could probably sell cheaper because you'd design it once, sell exactly the same thing worldwide. Ultimately, when the appliance vendors have to come up with all these permutations, it adds costs. And even for you, the user, then, the stuff is just more expensive, and they can't put engineering effort into adding unique, novel features. It also adds cycle time to how quickly these get delivered, because in the electrical appliance market, these things typically have to be retested for every market, and it just takes you longer. So this is it. At this point, I'm going to turn it over to James to cover some of the specific goals of the Container Storage Initiative.
Thanks, Steve. So primary goal of CSI is to provide a neutral standard protocol for COs to interact with proprietary storage systems. You're presented with a consistent set of behavior and expectations for both orchestrators and for vendor implementations of CSI. For vendors, this means there's less work to support n number of container orchestrators. For container orchestration systems, you get access to a broader storage ecosystem, you get to leverage open APIs, and you end up with looser coupling with storage backends. Some other goals, we're aiming to present a small set of APIs, but still enable many use cases. In other words, we want to drive towards kind of a lowest common denominator of APIs. We also want a low barrier of entry for CSI plugin writers. So it should be very easy to get up and running, building a new CSI plugin. Great. So from a high level, CSI presents a control plane interface that's largely focused on volume lifecycle. This interface is service-oriented versus command line interface. This allows plugin services to easily co-locate with other required long-running services, the Fuse daemons or Gluster or NFS services. Services are exposed via gRPC. Some advantages to this, there's understood mechanisms for proxying and load balancing gRPC calls. gRPC supports streaming responses, which is something that we're considering post V1. gRPC scales well, it's an open specification, and there's great community support. From a configuration and operation perspective, CSI places an emphasis on protocol over operational specification. CSI allows plugin supervisors, whether that's a container orchestrator or something else, to decide how to deploy and isolate plugins. CSI does not specify security protocols. An operator is responsible for protecting a Unix socket just as they would any other file system object. With respect to packaging, CSI does not mandate a container image format. The spec suggests that you try to use something that's cross-CO compatible. There's pretty minimal expectations with respect to supervision. For example, plugins should terminate upon request, getting a SIG term. And last, isolation of a plugin is not guaranteed, but it's very likely. So what makes up a plugin? CSI spec defines 3 gRPC services: identity, controller, and node. The composition of a particular plugin binary may depend on the deployment requirements. For example, a headless plugin will probably bundle all 3 of these services together. To illustrate this, there's some diagrams on this slide. To the right, we have a headless model. So you can see in the middle, there's the orchestrator, and around it, you've got the nodes where you've got your containers running. And on each node, there is a plugin instance running, and the plugin instance is exposing both the CSI controller and node services. On the left side, again, you've got the orchestrator in the middle, but you've also got a plugin co-located with the orchestrator, and that plugin is exposing the controller service. And then on the nodes where the containers run, that are on the outside, those nodes are running plugin instances that are exposing the CSI node service. The storage vendor is left to decide which deployment strategy is appropriate for their plugin implementation. And it's up to the operator to configure the container orchestrator according to the storage vendor documentation. So this slide shows the lifetime of a volume from creation to deletion. Shows the different states that a volume goes through as different CSI RPCs are invoked, and shows that a container orchestrator is driving the provisioning process. So a container orchestrator will invoke a create volume call. It will invoke the container publish volume call, which is like saying attach to a node, for example. It will invoke the node publish volume call, which is kind of like saying, hey, I want to mount this volume. So plugins advertise support for these lifecycle operations through capability RPCs. And a couple examples of those RPCs are the create and delete volume RPCs and the controller publish and unpublish RPCs. So that brings us to the API. It's going to be a brief walkthrough of the API. The API is really intended for consumption by container orchestrators, like Mesos, and not by end users. That said, it's still useful to understand what's happening under the hood. So we'll start with the identity service. This is important for version negotiation. A container orchestrator invokes the get supported versions RPC. The plugin responds with a list of supported versions, and then the orchestrator selects which version to use for future RPC calls to the plugin. All CSI endpoints are required to support this service, regardless of the deployment node. The next type of service is the controller service. This runs either in a central location or it can run on all the nodes themselves. It really depends on the deployment node, the deployment mode. The first call here, get controller capabilities, is important because it reports which RPCs are actually implemented by the plugin. And all these RPCs below there are the optional RPCs that may or may not be implemented by a particular plugin. So create and delete volume. Create volume accepts a name and capabilities, size for the volume that you want to create. Delete is the inverse. It deletes the volume from the storage provider. Controller publish and unpublish. Similar to, they started out as attach and detach. We decided those names really don't fit all the workflows, so we landed back on publish and unpublish and just prefixed it with controller. Again, these calls may be useful for centralized deployments. They could also be useful for headless deployments. It really all depends on the plugin implementation. The list volumes call is useful for discovering pre-created volumes. It does not imply that the create and delete RPCs are supported. The validate volume capabilities RPC allows a container orchestrator to determine if some volume, maybe a volume returned by list volumes, if that volume supports some set of capabilities and or parameters. And lastly, get capacity allows a CO to determine the available space on the back end, typically for a create volume call. Last is the node service, and this service runs on the actual nodes upon which volumes are mounted. So these are the nodes that are running all your containers. Probe node is an important call that checks the configuration of the plugin. It checks the required software, any required devices. If that call fails, the container orchestrator decides that the plugin's not ready to service requests. Node unpublish and unpublish, you can think about these like mount and unmount. Get node ID presents a consistent identifier for the node from the perspective of a plugin instance. And the get capabilities call is really just a placeholder for now. There is no meat there yet. And that was it. Brief walkthrough of the API. I'd like to turn it over to G now, who's going to cover how CSI is going to be integrated into Mesos.
All right, thanks, James. All right, James kind of explained like how CSI itself works and what are the APIs, and I'm gonna cover like what's our plan in Mesos to adopt CSI as part of the storage work. So what we plan to do for CSI integration is to introduce this new concept called resource provider. If you think about Mesos right now, we do have a way to customize the use of the resource. Like you can write your own framework to customize the use of the resource, but we don't really have a way to customize providing resources. Like right now, like this is like hard-coded. Basically, agent will boot up and discover a bunch of resources on the agent and report those resources to the master, but we don't have a way to customize that. And the whole concept of resource provider is trying to provide an abstraction in Mesos, allowing operators or cluster administrators to customize the resource providing part. It can be local or external. So local resource provider means that the resource it provides actually tied to a particular agent. For example, think about CPU, memory, disk. Some of the disks are local. And external resource provider are providing those resources that are not tied to a particular agent. Think about some resource like remote disk storage or IP addresses that not tied to a particular agent. So we do want to support these two kind of concepts, local resource provider and external resource provider. And if you think about that, the agent itself right now can be treated as a local resource provider, providing those traditional CPU, memory, disk resources, and plus the other part, which is task management part. And as I said already, so the reason we introduced this is because we want to allow users to do customization and extension, and also like Mesos don't have this concept called global resource or external resources, and the whole resource provider abstraction is trying to support that. And then, given that we have this resource provider interface that we plan to introduce, and for storage, particularly, we want to introduce a first-class storage resource provider. As I said, it can be both local and external. So we call local storage local resource provider and a storage external resource provider. So the storage provider will talk to the CSI plugin to get the available storage space from the plugin itself. For example, as James mentioned, there's a call in the controller service, get capacity. So that's something that we plan to call on to get the actual capacity from the storage provider and expose to Mesos as disk resources. So we want to abstract away all the details from the plugin itself and only expose like resources to Mesos masters. And the another job of the resource provider is trying to handle operations. For example, we have some existing operations like reserve, create persistent volume, and we want to extend that to support things like create block, create volume, which is like just creating provision and deprovision volumes from those storage providers. And the goal in Mesos support is pretty simple. I'll phrase as this. So the storage vendors just need to provide Mesos a single Docker image that contains all the CSI plugin bits and the configurations, and the Mesos will handle the rest. So this is kind of the high-level architecture of how we're going to integrate CSI into Mesos. As you can see here, we have a master and agent. We do have two types of resource provider here, external storage external resource provider and storage local resource providers. And we do things differently for those two different types. And for external ones, we run a controller plugin, controller CSI plugin in a centralized location, probably scheduled by a framework like Marathon or Aurora. The external storage resource provider will using gRPC to talk to the controller plugin. In this case, for example, we have an EBS plugin here. That the storage resource provider will talk to do dynamic provisioning volumes and deprovisioning volumes. And once the framework get those resources, disk resources, and trying to launch a task using those resources, and master will send a task to the agent. And there's another plugin for EBS running on the agent node. As James mentioned earlier, that for CSI, you do have to implement the node plugin interface and also the controller plugin interface. So the node plugin interface is going to be responsible to make sure the resource you want to use on that agent node actually shows up. For example, you want to do an attach to make sure, in EBS, you want to do an attach to make sure that the volume actually show up on the node, and then you want to do a mount. The whole reason in CSI that we want to separate node plugin from the controller plugin is because there are certain operations that has to be performed on the node. For example, file system mount and make a fast, things like this. So this is for external volume support. For local storage support, for example, if you have an LVM plugin, what we end up doing is actually we run both the controller plugin and the node plugin in the same container. So that same container provides two services, and the local storage resource provider will talk to that CSI plugin, as well as the agent will talk to that CSI plugin to properly do provisioning, deprovisioning, and make sure the resource actually show up on the node, which is kind of a node up in the local resource provider case. All right. So this is kind of the roadmap of storage support in Mesos. We're going to first do the local resource provider integration, and then integrate with CSI, and then we're going to do the external resource provider, because this is a little harder because we don't really have a notion of global resources inside Mesos, and it's a little harder to do that. So we decide to do that later, but it's kind of part of the roadmap, and also we want to integrate with CSI, and you can track the progress in this epic. So the LRP, local resource provider support, is targeted for the next release, and the ERP is targeted for the release after that, which is 1.6. So our release cycle is 2 months. So expect that to be available in 2 months, and ERP support is going to be the release after that, which is 4 months or 5 months. All right, now I'm going to hand over to Steve.
Thanks. So I'm back on stage again to represent CSI from a storage vendor's perspective, and what you see here is a quick overview of our XRay storage provider. At the top, you see container orchestrators. They go through the container storage interface spec and get to the XRay plugin. XRay actually is written as kind of an out-of-tree generic plugin that can have plugins implemented onto its own. So you see here that we can deliver NFS, block, VFS, as well as a number of other storage providers. XRay has been delivering persistent volumes to Mesos since October of 2015, so it has had quite a history. I'm sure that some of you in the audience have it in production today with the pre-CSI storage interface. Sunday, September September the 12th, we actually released XRay version 0.10, which is the first implementation of the CSI proposed specification in the world. Somebody had to go first. So at this point in time, as she said, it isn't supported in the container orchestrator yet. To my knowledge, it's not supported in any container orchestrator, but we felt that we wanted to get something out there in the world to enable projects like Mesos and DCOS to do work on the other side. And a key here is I don't want anybody to get bent out of shape, but I'm calling it a proposed specification because at this point in time, the container orchestrators get a vote on this, and we actually discovered a couple of issues as we were building the XRay implementation of a storage provider. So the spec, I think, is pretty darn close to what the final first official declared release spec will be, but technically this is a proposed implementation at this point. And should that change, I think we'll be pretty rapidly on board with adapting to whatever change takes place. This was made just to enable some early foundational work for the orchestrators like Mesos, Kubernetes, DCOS, Docker Swarm. Just kind of an architectural overview of what the plan is for XRay. We start with the container storage interface. We're planning on doing a conformance to spec test suite. We build XRay and the container orchestrators talk through the CSI spec, calls for gRPC to these plugins. These are the plugins that we just announced. So we've got coverage in public clouds for all the flavors of storage that you're likely to use on Amazon, EBS, CFS, S3, Google Persistent Disk, DigitalOcean block storage. If you run on-prem, we've got support for Ceph RDB. We've got 3 more or less generic flavors for block, NFS, virtual file system. For the Dell EMC on-prem product line, we shipped with initial support for Scale IO and Isilon. And then finally, we have support for OpenStack Cinder in this first release. Now, if you're using it in the pre-CSI interfaces, if you use XRay now, you're probably aware of this, but there's even broader support. But some of the support for all of the storage plugins that are available with XRay today isn't quite enabled on CSI yet, but it's in our roadmap. So the roadmap calls for the next release, XRay 0.11, roughly December of this year. I'm going to turn it back over to Chakravarthy then. I'm just one storage vendor, but the goal of CSI is to have broad industry support here. So, to emphasize that, I'm going to bring another on stage. And by the way, if there are any storage vendors in the audience, I'd be happy to talk with you if you haven't gotten on board CSI yet to discuss this. Chakravarthy?
Thank you, Steve. We are Diamanti. We are actually developing storage and network solutions for containers. So initially when we looked at Kubernetes and we realized that there is no way you can develop your plugin out of the Kubernetes code base. All your plugins has to be inside the Kubernetes code base. And it's very tightly coupled with Kubernetes release cycle. So we developed Flex Volume. It was a good start, but it was limited to one orchestrator. It provided a simplified, It provided a simplified vendor-neutral interface, but it only supported one orchestrator. So now here comes CSI, and we are very excited to be part of the CSI community, and I'm actually grateful to the ecosystems for bringing this together and making it happen. So thanks to Google, Mesos, Docker, and Cloud Foundry. So they have worked hard to make it happen in the last few months. So what is CSI from a vendor's perspective? It is one storage plugin interface to support multiple orchestrators. So as a vendor, you develop one plugin, and it's going to work with multiple orchestrators. And without this, we had to develop multiple releases of our plugin with multiple orchestrators, and we are spending a lot of time in development and testing these various environments. So with a united ecosystem now, there is a single interface, and we don't have to keep on supporting all the test metrics which you used to. And also with the united ecosystem, what we realized is every orchestrator was innovating separately, and they're developing their own interfaces. So, and there was a lot of duplication in the effort. So once we got together, actually we can see that like there's only now one interface, and there's a lot of new innovation happening in that area, and there is no duplication. And as a vendor for our customers, what this gives is a proven interface so that people are easily and ready to adopt the container infrastructures. Okay, and thank you. So,
Okay. So we're getting near a wrap up here, but if you're wondering who's involved with the CSI, this is a broad initiative. So you see there the logos of essentially all the major container orchestrators, as well as a lot of the major storage providers. We had to do this deck a couple weeks ago because the Linux Foundation wants the decks submitted early. So I may have even missed a few here. It's hard to keep up because this thing is gaining momentum. So if you're a storage provider out there that is committed to doing CSI enablement, let me know so that if I deliver this deck again, I can add you to the chart. What we're delivering now is just the first step. So I want to be open about what isn't in CSI, and the list is up there. But on the roadmap past the initial release, we have plans to support snapshots, volume resizing, quotas, support for containerization of the Windows OS, and then finally, user ID and credential pass-through all the way from the container orchestrator to the storage provider, because some storage providers actually have features that rely on user identification as a means to implement additional forms of security. Finally, in community, this stuff is underway now. We've got a number of storage providers working on this, as well as all the major container orchestrators. But there's room here, if you're a user of a container orchestrator, a consumer, to get involved in this program. You know, and it's a great opportunity because I mentioned on the roadmap we have plans to support Snapshot, which would enable backup strategies and a number of other features. But if you've got features that you really want, I'd invite you to get involved with the container storage interface group and get your feature wish list on the table. It's currently operating in the form of an online 1-hour meeting every 2 weeks, and there's a link to get there. There is also a Google group that supports a mailing list. So you can look at the historical communications there to get a feel for where this has come from and where it's going. Why would you want to get involved now? Well, you can shape this at this stage. It's still in the formative stage, but more important than that perhaps is that if you're somebody who runs stateful applications at scale, and these are critical to your organization, getting involved at this architectural planning stage is a great way to train your staff. You know, you're going to get a thorough understanding from top to bottom as to how this is put together, which should enable you to do some serious troubleshooting and maybe making plans for how you'd implement your own infrastructure of, you know, laying out your compute nodes, your storage interfaces, what kinds of storage you'd like to procure. And often as you see these architectural decisions made, you get to a point where you're kind of at an expert level understanding how these things work behind the curtain under the covers. And that's a great opportunity because if you wait till it's shaped and formed, some of these opportunities for just watching why these decisions were made are lost. I mean, theoretically, you could go back to do Google searches to find a lot of these notes, but actually coming to these meetings, we occasionally might even have some face-to-faces, is a good opportunity if you're really a scale user where this is critical to your business. That said, that's our presentation. It looks like we've got some room for some questions here if anybody's got any. Yeah, we have one there.
So on one of G's slides, you mentioned that the goal was to allow the storage providers just to supply a Docker image. And I was wondering if you could talk a little more about that, how that fits in. Is Mesos going to run that Docker image to run any binaries that provider needs in order to do their stuff? What's the lifecycle plan?
Yeah, so the question is, as I mentioned in one of the slides, that Mesos is going to take just one Docker image name from storage providers and just take care of the rest, and how that workflow, how is that workflow, how does that work? I think there's a configuration. So as I mentioned, there's a storage resource provider, and there's a configuration for that. And when you actually you need to specify the Docker image name in that configuration, and you can hit some endpoint on the agent, or if it's a remote resource, like external resource provider, then you can use Marathon to launch that external resource provider and then talk to Mesos master. And we need to run for the local resource provider, there's a plugin, there's a single plugin container. So can I go to the slides?
Sure. So
Go to the architecture slides. Down. Yeah,
That?
that one, yes. All right, so if you see that graph, so the local, you have a configuration that you pass to the storage local resource provider, which is a Docker image name for your plugin. And the storage local resource provider will make sure that this plugin container is running on that agent using the same containerizer we have inside Mesos to just run that container. Make sure that's running, and we'll talk to that container using gRPC, and also monitoring the health of that container. So when it fails, we'll restart and make sure that it can talk to that again. Yeah, for local one, it's like that. So you just need to tell Mesos about the configuration of that storage local resource provider, which contain the image name, and then we can take care of the rest. For external ones, most likely the storage external resource provider is going to be launched by another scheduler like Marathon or Aurora, and then it has its, like, one way to do that is you package the container inside the same storage resource, external storage resource provider. So you, as a pod, for example, that you can talk to each other using Linux domain socket or local address. And then there's a container image name in the configuration of the storage external storage resource provider that is going to be passed through from Mesos master to the agent when you're actually launching a task. And there's a component in the agent when it actually wants to make sure that resource appear on that node. It will try to see if there's a container, no plugin running or not. If there's not, it will try to spin up that node container. And the reason you can get the name of the container is all the way passed from the master to the agent in part of the configuration of the external resource provider. Does that answer your question? Yes, thank you. Cool. The question is where the configuration of all these volume? Sorry. The question is where the configuration of the plugin container resides, and the answer for that is it depends. So different plugin vendors has different configurations. For example, when you're launching a plugin container, you may want to specify something special, environment variable. That's part of the configuration that you supply to the storage local resource provider or storage external resource provider. It's a JSON config that you can specify what's the image name you want to use, what's the command, what's the environment variable. Pretty much the same as when you're launching a task, you have to specify those things. We use the same mechanism asking you to specify those things, the command info and the container info of that container.
Yeah, so the question is, how does CSI expose access to additional metadata about the volume so that a container orchestrator or someone can reason about that to place a workload? So the CSI spec defines two things that are part of a volume handle. One is the ID, and one is metadata. And so it's up to a plugin to expose whatever additional metadata it wants about that volume through the volume metadata protobuf. It's an opaque field. There's no standard keys. So if you end up writing specific logic in your CO, then you're kind of coupling it to a particular storage provider. If you're an end user, then maybe you're coupling your app to a specific storage provider. There's no conventional set of keys for that metadata field, but the information can be there as long as a plugin implements support for that. Does that answer your question?
Yeah, so the second part is what's the plan for Mesos to expose that information to scalers, for example,
Yeah, so basically like when you do a crate volume, if you go to the repo right now, CSI spec repo, so in a crate volume, the return value actually give you a volume ID and the volume metadata. We're going to stick into the resource that we provide. So the resource provider is going to get that information and then create a disk resource. One of the metadata we stick into that disk resource is going to contain the ID as well as the metadata. But whether the scheduler wants to leverage that information to do scheduling decision, that's kind of like a question mark. Some people might prefer like, I don't want to do a like logic for like a given specific storage provider because that metadata is kind of very specific to that given storage provider. You probably don't want to do that. So in like a different approach is you provide some kind of high-level abstraction, like say like a storage class or a profile where you specify a name of that profile, and then you have for each different provider you specify different parameters and things like this, and then the scheduler will based on the profile name to make scheduling decision rather than just based on those raw parameters and the metadata from the volume. So it depends on what the direction you want to go. Mesos is not going to be opinion on that.
And just one final bit of information, because the question was kind of related to placement. There's an open action item right now in the CSI working group. One of our partners, Saad from Kubernetes, is working on the concept of domain and how domain is going to fit into the CSI spec and how that would affect placement of volumes in the cluster. So it's kind of an open ticket. It's an open item. If you want to be involved, I recommend attending the community syncs that we have.
Yeah, just add one more thing. I think domain is pretty important because if you think about EBS, right? Like you do have some restriction on where you can use the resource. We use that volume. If you create a volume, EBS volume from zone A, you cannot use that volume in zone B. You do need to expose some like domain or topology information to the framework so that it can make a better placement. I mean, you don't want to place the volume in a zone that you cannot use the volume. Any other questions? Okay, we are out of time. If you have any questions, feel free to come over and ask. Thanks everyone.